Right. So, welcome to the second day of our workshop, and today actually we are going to discuss about the remaining part of the first day, the loops and the function section. So we will be discussing about loops and functions, and we will be moving on to the next part today, Python modules, and under that we will be discussing about Numpy and Matplotlib in detail, right? Okay, so I'm actually, first of all, I'm sorry about what happened yesterday. So I had an family emergency to attend, so therefore I couldn't able to conduct the class yesterday, right? So what we are going to do, we will have another session on Saturday 4 to 7, Saturday 4 to 7. So in that session, we will be covering the last last day's content will be covered on Saturday, right? So it will be like one day shifted, and everything will be shifted by all the uh, uh, days are shifted by one, right? One day, right? So we will be conducting as usual, but you have to come on Saturday as well, right? Okay, therefore, let me start the session now and conduct the section loops, right? And we have actually in the first day we discussed about the basics of Python, and we got to introduction to Python, and then we discuss about the variables and strings and Python input, and thereafter we discuss about the arrays in Python, like the tuples, dictionaries, and lists, right? So we discussed about these topics, and thereafter, finally, what we did was we actually go to the decision making part, right? Decision making part, and we discuss about how to perform decision making in Python, right? So that's what we did on last time, right? And okay, right. So let me upload this one as well. Okay, let me share it from here. Right. So yeah. So loops, one of the most fundamental concepts you are going to find in programming, not in Python, but all the programming languages use this concept, loops, right? So loops are used when you need to get the same thing done again and again, right? So if you want to repeat a code segment, or if you want to repeat something, if you want to repeat a set of instruction, a code segment, or set of code, anything, if you are going to repeat the same thing, then you have to use loops in the code, right? So then you can obtain the behavior, the repetition, right? So that's the idea of loops basically, right? So in Python, right? Python, we have two main types of loops, for loop, and the other thing is the while loop, right? So only two, for loop and while loop. So those are the two kinds of loops available in Python, right? Loops available in Python. Okay. Right. So give me a second. No. Yeah. So that's how the loops available in Python, and we will discuss about for loops first, and thereafter I'm going to move on to the while loops, right? So if you take the for loop in Python, it's quite straightforward, right? So this is an example of like implementing a for loop in Python, right? So if you want to like, let's say now, if you want to write this, or if you want to print this 10 times, right? Let's say that you want to print this 10 times. What you can do is you can like use this kind of a loop, right? So in Python, in for loops, you have three parameters to be provided, and also the loop control variable. Now in a loop we have something called loop control variable. So in this loop it's I, right? I is the loop control variable. So what's the idea here is that this I simply controls the loop, right? So loop, again, something that we are going to use for repetition, to perform repetition. And this repetition and everything, the loop is controlled by this variable. So that's why we call it the loop control variable, right? So anyway, now when you have a loop control variable, right? So this loop control variable, the behavior of this loop control variable is defined by these three values, right? The behavior and the behavior of uh, the loop, the loop control variable is defined by these three numbers, so these three values, right? So the first value is known as the starting value, and the second value is known as the ending value, and the final value is known as the increment or the step size, we can say, right? Increment or the step size, simply, right? So here now uh, the starting value, let's say 0, right? The ending value is, let's say 10, right? And the increment is 1, right? So what happens? This I will iterate, right? I will iterate starting from 0 up to 9. So you know in Python, the upper limit is always less than 1 less than the given value. So what happens? The I will iterate from 0 to 9, and this is the step size. That means for each iteration, the step size is 1. That means the I will be incremented by 1, right? So that means what happened? Here I start from 0 and it go up to 9, 1 less than the given value. Upper limit is 1 less than the given value always. So therefore, I is simply the step size, right? So here now what happens? This loop will run 10 times what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 0, 1, 2, 3, 4, right? 5, 6, 7, 8, 9. So 10 times, right? So if you can't understand it, let me show you the I value, right? Then you will find that I is changing, and I is changing from 0 to 9, right? So if you change the step size, still it goes from 0 to 9, but step size of 2, right? 0, 2, 4, 6, 8, right? And you can do anything, right? So let's say minus 10 to plus 10 with increments of 2, see, right? Or else 10 to minus 10, increment size is, let's say, minus 2, right? 10, 8, 6, 4, likewise. So very simple, the starting value, ending value, and the step size, right? A step size can be either a positive value or a negative value, right? Got it? So very simple. But there's one more important thing that it's not necessary to provide all the three values all the times, right? It's not necessary, right? So for loop, you can run the for loop with two values as well, right? What happens when you are going to provide two values, still it runs, but the first value is similarly as the same as like the same case earlier. It will be the starting value and the 10 will be the ending value. But here only we are going to provide only two values. No third value is provided, right? So third value is the step size. So step size is not given here, but still the loop runs. What happens to the step size? Step size will be assigned to default value, right? So the default value becomes what? Default value becomes, yes. So we are not going to provide the step size here. So step size will be considered as its default value. So what's the default value? Here, can you see? Yes, step size. The third parameter is not provided here, but still it runs, right? So then the step size is assumed as what? Huh? Yes? Yeah. Getting answers, very good. Yes, exactly. So it is assumed as 1. That means what? Right? So 0 to 10. And we are not going to provide the step size. So step size will be considered and it will be assumed as 1. Right? So you can run a loop with starting value and ending value as well. Right? So that means when you are going to provide 2 values to a for loop, that will be taken as the starting value and the ending value. Right? And also you can run, now here you can change anything, right? So I mean, you can change it like -10 to +10, yes. But always what happens is the step size will be +1, right? So step size will be +1 all the times. You can run the loop with a single value as well, right? Only taking a single value. So then what happens? Huh? Right? So this will be taken when you are going to run the for loop with a single value. That means what? The loop will like it's going to assume that the starting value is 0 and the step size is 1, right? And the value that provided is the ending value, right? So when you are going to provide a single value to the for loop, that given value will be taken as the uh, upper limit or the ending value. And what happens, the starting value will become 0 and the step size will become 1, right? So that's what happened here. That's what happens here, right? Got it? So usually most of the times, right, most of the application, our loops, most of the time they run starting from 0 and with the step size of 1, right? Majority of the cases, this for loop starts from 0 and like go up to a given value with the step size of 1, right? Usual, most of the usual cases, right? Therefore, this is what we use most of the times, right? This is what we use the most of the time. But if you have a special case like this, then probably you
Can we
can,
give one negative?
yes.
Can we give negative values? Like for I in the range of -20, will it accept or
You mean here? No, I think yeah.
yes?
As I know, it won't work. No, it won't run. Right. So if you want like make it like decreasing, then you are probably use the all 3 values. Right. This won't work since the here like -10,
Okay.
it's like 0 to -10. So the step size should be minus something, right? So it won't work. So if you want like do something like this, then you have to use the full for, right?
Okay, thank you.
Okay, right. Great. So yeah, so that's pretty much about, I mean, the for loop, the implementation of for loop, right? So this is how we are going to use the for loop simply in our implementations, right? So next thing, the next type of loops is the while loop, and quite simple, but I mean, this is similar to the while loop in other programming languages. The syntax is quite the same, right? So the starting value, now we have all the values, but they should be given as, I mean, they should be provided as separate values, right? So the starting value you are going to provide here, right? And the starting value you provide it here, and you give the ending value, right? The ending value or the terminating value as a condition, right? So you provide it as a condition here, and this is uh, the step size, right? And one important thing, I++ is not available in Python, right? I++ is not available in Python. It won't work, but right. So you can provide like I equal I plus 1, or you can provide like I plus equal 1, right? So both of these you can provide. But I++ won't work in Python, right? So the starting value, right, and the ending value as a condition, and then the step size like this, I equal I+1. So you have to provide the three values separately. So for loop is the, yeah, for the most of the application, the for loop is for loop is better. It's quite easy to implement the for loop, right? Right here we have to give all the things manually, like the condition, starting value, and the step size. Everything we have to provide them manually. But the thing is, now when it comes to a um, for loop, it's quite straightforward now, right? See, right? So very simple to use, implement a for loop, right? It's quite simple. See, the three values are given like this, and you can implement it very simply. But while loop is bit right, not straightforward to implement, right? So you have to give these values separately, and they have something to do here. But therefore, like most of the times we use the for loop, right? Most of the times we use the for loop, but when you have a infinite loop to be implemented, right? Infinite loop, is there any application where we want to use infinite loops? Yes, we will find them soon, right? So there are some applications we need to implement infinite loops, right? Forever running loop, right? So in those cases, it's easy to use a while loop than using a for loop. Understood? So when you are going like implement a for loop, infinite loop, while loop is quite straightforward to implement, and like for loop is bit hard. Therefore, right, so what I do, simply I use for loops for all the applications. But if I want like implement a infinite loop, then I use the while loop. Here, this is how we are going to implement a while loop, while true, right, like this. So you can see it's a forever running loop, right, an infinite loop, you can see, right? And the other thing is that you can either put true or one here. So while one, same result, right? See, a for loop, a forever loop or infinite loop, right? So the idea here that it's quite easy to use a while loop to implement an infinite loop. So what I do, right, all the other uh, loops, other instances, I use a for loop. But when it comes to like infinite loop, I use a while loop, right? Got it? Right. 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 Then there are a few things to be discussed uh, about the for loop, right? Some advanced things that we can like yeah, advanced things that we can do with the for loop, right? So let me explain you. Now here we have a list. Let's say we have a list here, right? And I'm going to run. Okay, forget this one. For I in range, length of my list, right? So length of my list, we discussed in the first day. This will provide you like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Okay, so the length is like 11. So what will be the starting and ending value of the I here? Starting and ending value of the I? The length is 11. So what's the starting value and the ending value of I? Any idea? Yes, exactly. Oh, no, not 0 and 1 I. Right? So you have 0, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 11 values here. Therefore, it will go from what? 0 to 10, right? 0 to 10, right? So instead of printing I'm going to print my list I. So what happens? Now you know in lists we have indexes, right? Like 0. Okay. Okay. Anyway, 0, 1, 2, 3, up to 10, right? Right? Got it? Um, right. So I'm going to print like not I but my list I, right? So that means my list 0, my list 1, my list 2, my list 3, my list 4, like my list 10. So what happens, this is something obvious, right? So I think you are familiar with this. So it simply prints the value of the uh, each value of the array, right? Since it's going to print my list type, like my list 0, my list 1, my list 2, my list 3, up to my list 10, right? Up to my list 10. Got it? So that's why you are going to see these values, right? I am printing my list 0, 1, 2, 3, up to 10, right? Got it? So this is how we are going to do, like if you want to access values in a array, right? So if you want to access values in an array, right? So this is something that we are going to do in other programming languages as well. So we can iterate a loop through the, we can iterate a loop with I, and each time we can print the my list I, or the elements of the array using I, right? Use the index and you can print it like this, right? So here now you can see if I print I, right? If I print I and my list I, so you can see, right? 0, that means my list 0, 1, my list 1, my list 2, likewise. So it actually print the index, according to the index, it will print like, it will print the values, right? The array, the values in the array, right? But in Python, we can do it in a different way, right? So here we iterate a loop and we iterate it through I, where we are going to run the loop with the I value starting from 0 and the end of the loop, right? But without doing that, what we can do something like this. For I in my list, so carefully see the difference, right? For I in range, so here we iterate this I value from 0 to 10, right? But here no, for I in my list, print I, right? So then you will get the same thing, right? You will get the same thing here, right? Got it? So in this case, what happens? Now here, I goes from 0, 1, 2, 3, 4, up to 10. All the iterations, what we do is we print my list I, right? So that means my list 0, my list 1, my list 2, my list 3, likewise. But here, no. For I in my list, so if you are going to do this, what happens? I directly becomes the values in the array, right? I directly becomes the values. I is not going from 0 to 10. Got it? Here, I is not going from 0 to 10. Instead of that, what happens? I goes from like what? I goes from like I will be assigned to each value of the list. Right? I will be assigned to the each I will be assigned to each value of the list. Got it? Right. Understood? So this is one method, another method, right? So this is quite straightforward and it's easy, right? Here you can see. So this is what happens. Right? In this case, what happens? Like I will be changing from 0, 1, 2, 3, 4, 5. And what we print is, we print my list 0, my list 1, my list 2, my list 3, likewise. Then you are going to get these values. Right? But here what happens? We go from like I in my list. So what happened? I will be, right, assigned into these variables, these values in the list. I directly become those values. I is not like 0, 1, 2, 3, up to 8. No. What happens? I will directly become those values. Right? So I becomes like my list 0, my list 1, my list 2, my list 3. It directly becomes that value. Right? So two different things when it comes to for loop. Understood? Right? Right? So here, but there's another thing that we will miss the index, right? Here we will miss the index in the sense that, okay, we don't know what this is, like the zero element, first element, second element. We don't know the index, right? We just know the value, right? We just know the value, we don't know the index, right? Therefore what we can do, there is another method, not another method, but here we can add this function enumerate, right? We can add this function enumerate we can say, right? So you know what happens here, right? If you have this kind of a list, right? If you have this kind of a list, let's say I becomes this, I become this, I become this, I become this. Likewise, I changes from those values, right? Therefore, what we can do, we can get this enumerate and we can pass the array. So this will give you both the index and the value. You can get both the index and the value. So if I print now here you can say it gives only the value, right? Not the index. But if you use this function enumerate, what happens? This provides you both the index as well as the value. Got it. So you can use this enumerate function to simply get the uh, uh, the index. If you want to get the, I mean, if you don't want to get the index and if you only need the value, then you can use this. But sometimes you might need the index as well. So therefore you can use this one, I value enumerate. So this provides both the value as well as the index, right? It provides both. Right? Okay. Right. 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 The other thing is that you can use loops to create arrays. Right? You can use loops to create arrays, right? Let's say my array equals curly brackets, sorry, square brackets, and sorry, right? So here now if you print the array, got it? So now what happens here, inside the list, what I have given is a loop, you can see, right? So using this method, what we can do is we can simply create an array using a loop. Right? We can create an array using a loop. So how it's done? Simply, you are going to run a loop like this. You are going to run a loop like this. I in range 10. Right? So in order to understand, you have to split this to two parts. Right? So this one you already know, right? This is a loop. This is a for loop. Okay, so how many times this loop will run? Any idea? How many times this loop will run? Yes, quickly. Yes. Yes, how many times this loop will run? Yes. So this runs 10 times, right? So that means there will be 10 values in this array. So this loop actually decides how many values are there in this list, right? Right. So this loop will run 10 times. That means there will be 10 values. And this thing decide for each iteration of the loop. So you know the loop will iterate 10 times. That's something that we have already configured. And this value, the value given here, right? The value given here, what? Huh? The value given here decides for each iteration what the value to be assigned to the list, right? The value that going to be assigned to the list, right? So this decide that one. Got it? Understood? So for each iteration, this loop will iterate 10 times. Right? This loop will iterate 10 times. For each time, we are going to assign I to the my array. Therefore, you are going to see this kind of a thing, right? So what happens if I do something like this here? This loop will run 10 times. For each iteration, I'm going to assign 0. Right? For each iteration, I'm going to assign 0. So therefore, you are going to see something like this. Right? Got it? So this decides how many values there will be in the array, and this decide the value of each value that will be assigned to the list for list for each iteration. Right? Got it? Right. So here now again you can see minus 10 to plus 10 with two-step increments, and we assign like I into I. Right? We assign I into I. Got it? Understood? Right? Got it? So using this kind of a method, what you can do is you can simply create a array using a list. I mean array using a loop, right? Array using a loop. Got it? A list using a loop, right? And right. Yeah. So the next topic is the loop control statements, right? Loop control statements. So this is a bit interesting and I mean a useful one, a useful topic, right? Loop control statement. So you know a loop is like a iterating thing, right? Iterating thing in the sense like whatever the code that we are going to include inside a loop will run repeatedly, right? It will run repeatedly. So that's what you mean by the loop, right? So when a loop is running, right? So when a loop is running, what we can do is like we can control it in the like that means now while the loop is running, right? We can use this control statement variables inside a loop to control the loop, right? So we have three main: break, continue, and pass, right? So what we can do is we can include break, continue, and pass. So these control statements inside a loop, right? That's what happens now. For example, here, um, right, I'll do it like this, right, here, right? So we have a set of numbers here. Numbers in the sense that list name is numbers, right? So we have several numbers. And what I'm going to do, I'm going to like go through, let's say, without doing anything. If you do something like this, you know that it will go through the whole array, right? Something obvious. For value in numbers, I'm going to print the value. For I in numbers, print I, similar, right? So what happens, it go through each and every value of the list, right? This loop will iterate through each and every value of the list, right? So here what I'm going to do, for value in numbers, right? For value in numbers, so I'm going to go through the loop again, and I have like a special case here, a special condition checked here, that I'm going to check whether this value is equals to 10, right? So the loop iterates through the values in this list, right? And if someone, I mean, if in some instant, let's say, in some instant, let's say that you are going to find 10, right? You are going to find 10. In that case, the loop will be broken, right? So loop will be broken here, right? For example, if you run this, okay, so the value will go like 11, 33, 55, 39, and suddenly you find 10, right? So when the value becomes 10, we break the loop. So the loop will be terminated from there, right? But originally, in the original case, loop should run through all the values, right? The loop should run through all the values. But here, we are using a control statement. We are using a control statement that we are trying to control the iterations of the loop, right? And what happens when the value becomes 10, we break it, right? Now, this is not always to needed to be like array, but when some condition is satisfied, what you can do, when some condition is satisfied, we can, what we can do is we can break the loop, right? So we will use this in image processing, right? So in order to access our cameras from our computer, we use a while loop, and that while loop, when we want to stop that video feed, we use the break, right? We use a break. So there are lots of practical examples where we can apply this break. So break is simply used when you have a loop, and if you want to terminate the loop when a condition is satisfied, right? When a condition is satisfied, you can use this break statement control variable, right? Loop control variable, right? Break statement control variable. So the other thing is the continue, right? Other thing is the continue, right? So what do you mean by continue? Uh, right. Right. So what happens here? The continue quite different when compared with the break, but it actually works like this. When this condition is satisfied, it skip that value, right? Or in other words, we can say it skip this iteration of the loop, right? So you know that this loop 11, 33, 55, 39, 10, 75, 70, sorry, 37, likewise it go, right? So here you can see when the value equals 10, it skip it. Skip in the sense, now when this condition is satisfied, what happens, right? If this condition satisfies, what happens is that it skip it, right? It's not go and perform the remaining part of the loop, right? It won't perform the remaining part of the loop, right? It won't perform the remaining part of the loop. Instead of that, what it will do, it like simply continue. It simply skip that value, right? It simply skip that value. So you can see now, okay, 11, 33, 55, 39, and 10, you can't see 10, right? What happened? The 10 is skipped, and the loop skip that iteration and go to the next value. So if you like, when the condition is satisfied, right? When the I mean, this is not necessary to be a value, but when you run a loop, when you are running a loop, let's say some condition is satisfied, a particular condition is satisfied, and at that moment, if you want to skip that and go to the next one, then you can use a continue, right? The continue, right? Okay, so I think you are familiar with the break and the continue, and the third one is the pass, and pass simply and technically it does nothing, right? I mean, it's like it's not there. Let's see. I mean, this is like this, the same output you are going to get, right? See, no change, right? So pass does nothing. Here you can see statement pass right? The pass statement in Python is used when a statement is required syntactically, but you don't want any command or code to execute, right? That's like, I mean, this pass does nothing actually. This pass does nothing, but this is useful when this kind of things, right? So let's say that you have a loop like this and you still don't know what, I mean, you are not going to implement the loop here, right? You don't have an idea how to implement this loop, right? But you will do it later. Now let's say that you want to write some another code here, right? Let's say that you want to take an input, right? So and you want like, the thing is that here, right? So what I'm trying to tell you, okay, so there's a loop, there should be a loop, but still you don't have an idea, or still you don't need to define it yet, right? So there should be a loop, but you are not going to define it now due to some reason. You will define it later, but you can't keep it like this, right? You can't keep it like this. See, you are going to get an error, right? So the functions, loops, if conditions, they cannot be kept empty, right? They cannot be kept empty, right? You have to include something. Therefore, in this kind of a situation, what you can do, you can use a pass, right? You can use a pass. So nothing will happen, but no any error is also given, but the code runs without any issue, right? See, therefore, if you have not implemented something yet, and if you are like implementing it later, it can be a function, it can be a loop, it can be a if condition. There you can use a pass statement, so it prevents giving you an syntax error, right? It prevents you from giving an, I mean, it prevents the code from giving an syntax error, right? Right. Very right. Okay. Okay. Now, from the things that you have learned up to now, right? From the things that you have learned up to now, I have provided you an quiz, right? I have provided you an quiz. So what I'll do is that you can freely go through this material, right? You can freely go through this material, and what I simply do, right, is I will I'll provide you some time, right? I will provide you some time, and try your own to solve these problems and implement the code. So here actually the codes that I mean, the questions that I have provided, so this will be based on arrays, I mean, lists, tuples, dictionaries, as well as decision making and loops, right? So all the content that we have covered up now, this is implemented using this quiz is implemented using the questions uh, from the content that we have already covered up now, right? So I will keep it to you, right? I'll let you to do this, like you can do it freely. Then I will provide the correct answers later. So you can go through them and compare it with your answers that you have provided, right? So if you can simply go through the uh, things that we covered up to now, you can simply implement codes for these questions in the quiz 3, right? So I will give you some time, and I will first let you do this, and then I will provide you some answers to compare this and get your problems clarified, right? Okay, all right. Okay, so any questions up to now from loops or decision making, anything you need to clarify? Yes, quickly. No, everything is fine. Yes.
Akshila, can you hear me?
Yes.
Yeah, are we supposed to do it now?
Yeah, I can hear you. Yes.
Yeah, are we supposed to do it now? Like now?
Yeah.
Okay. Thanks.
Uh, Sorry, I couldn't get you. Any question?
Uh, I was asking that are we supposed to do this quiz right now?
No, 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 not now, not now, not now. You can do it
Not now,
later.
right?
Yeah, you
Okay.
can do it later. Leisurely, you can
Okay.
do it.
Okay.
Yeah.
Mhm.
So I will provide the
Yeah.
answers later, right? I will provide some sample answers
Okay.
later. You can then
Yeah.
compare it
Yeah.
with the answer.
Okay.
Okay,
Thank you.
right. So,
Yeah.
any other questions? Okay, so then shall we move to the next part and quickly finish this off, right? So the next topic is functions, and very as usual now all the concepts are fundamental concepts. So every topic is important, right? So these are very fundamental things in programming, like decision making, loops, arrays, variables, functions. So all of them are very fundamental things. So each topic is yeah. You mean yeah, part 3 I will provide it, and 5 as well. Okay, so yeah, so let me share this with you. Right. Sorry, I have to share them to all, right? Right. So function. So what do you mean by a function? Function is a code segment. Simply, function is a code segment. That means set of codes. All right. But what's the specialty about a function? Yes, it's a general set of codes. Set of codes to do some task, right? It can be one line code or it can be like code segment with many code lines. But the specialty is once you define a function, that code that you have included inside the function can be used again and again. Or simply we can say it is a reusable code segment, right? So function is simply a reusable code segment. So in the standard term or like the standard definition, it says a function is a block of organized reusable code that used to perform a single related action, right? So the main thing, the most important thing when it comes to a function is the reusability, right? The reusability, right? So in Python, this is how we are going to define a function, right? So the function is always starts with the keyword def, right? No matter what's the function, that function starts with def, right? Any function in Python start with def, right? Then comes the function name, right? Then comes the function name, right? Then parentheses. Inside this parentheses, you can provide parameters, right? That's all. And the function body, right? So here also you can see keyword for the function definition. This should be there all the times. When you are defining a function, the first word should be def, and then the function name. So this is a user defined name, a user given name, a customized name, and we can provide set of parameters optional. It's optional. No need to provide parameters for all the function. It's optional, right? Got it? Right. So this is what you call a function. This is how we are going to define a function. Right? This is how we are going to define a function. So this is called the function definition, simply, right? And then the function call. After a function is defined, what you can do, you can call it, right? For example, here we have a function called function1, right? Function1, and no parameters given in this case. No parameters is given. So I have two print statements here. This is my function, and like it prints some stars, right? So this is the function definition. So I have defined the function, and here I'm going to call that function, right? I'm going to call that function here. So what happens when you call a function, whatever the function body is will be executed, right? In a function, you have set of codes, right? When the function now in the function definition, you are going to define some code segment inside the function body. Then what you can do is you can call that function. So function1, this is how we are going to call the function. Once a function is called, what happens? The body of that function, the code segment inside that function will be executed, right? So this is how we are going to do it once. And again, if you call the same function, the same thing happens. So this is why I call like a reusable code. Here, you can call it many times, right? You can call it anytime you want, right? That's what it said, kind of reusable code, right? A reusable code. So here now I have defined a function with some parameters. So I have parameters like A, B, and C. And inside the function, a simple thing is done. I print those values. I print those values. So that's what I have done here, right? So I have a function here called my function. And inside the function, like I take 3 parameters, and those 3 parameters are printed here. Those 3 parameters are printed here. So that's like this, right? Here example. So these are the parameters. Now parameters are optional. You can define functions without parameters, right? It's application dependent. It's application dependent, right? It's application dependent, but you can define functions without parameters. And the thing here, when you have parameters like this, right? When you have parameters like this, you have to pass values to those parameters. Like, okay, when you call the function, right? When you call the function, what you have to do is you have to pass parameters, right? For example, here I pass like, okay, 10, hello, and 20.5. First one passed to A, the second one is passed to B, and the third one is passed to C, right? Then those will be printed. So in the function call, you have to pass these parameters in the function call, right? Okay, so this is my function A, B, C. Right? This is my function A, B, C, which takes 3 parameters, right? And I print those 3 parameters. So here you can see I pass some values. I pass some values here. So what happens? Simply, these values will be like passed to, okay, A, B, and C, right? So A, B, and C are printed here. Got it? Right? So that's a function with parameters. Now, this function is without parameters. That means it don't take any parameters. Right? The function one don't take any parameters, but my function takes parameters like A, B, and C. Right? So when you have we have function with parameters, you have to pass them. Right? You have to pass them. Right. So here now, right. So the reusability, right? The reusability. So you can use it again and again, right? You can use it with some other values as well. Now in Python, we are not worrying about the data type, right? So you can pass anything to any parameter, right? The data type is not going to be a matter. And the other thing is no return type in. If you are familiar with other programming languages like Java, C++, or C, there's no return type in Python, right? No return type is going to be provided in the Python function. Just the def keyword, right? Just the def keyword. No need to provide the um, um, uh, function, right? I mean, no need to provide the return type of the function, right? Okay. So here now we have a very useful function. I mean, I wanted to explain how, I mean, for what kind of applications we can use a function, right? So here, see, we have a function called cal average, right? A function called cal average, and I take a parameter called a. Then I pass this kind of array or a list here. So this one, let's see. Right? So this array will be taken by this a. Now I wanted to show here that the data type or whatever the parameter you are going to pass to a function is not important, right? You can even pass an array. So I pass this array. I pass this array, right? And that array is taken to A. And what we are going to do? We calculate the average. Sum of the array, sum of all the values, and the length of the array. So addition of all the values divided by the number of elements, which gives you the average, right? Right? Got it? So you can define functions like this, very simple functions like this. I think the average becomes large due to this value, right? If you reduce the value here, this one as well, you'll probably get a simple value, right? Right. Okay. Got it? Right. Now the next thing, the arguments of the function, right? So when you have arguments in your function like this a, b, c, right? That means to the function you are taking some value from the function call, right? That means simply when you call the function, it requires, right? It requires set of values, right? So this function works with some parameters. That's what it says, right? At the function call, you have to provide those values. For example, the cal average function looks for an array, right? So when you call the cal average function, you have to pass array. So what we are going to do, we pass this array, and it will be like average will be calculated and the average is printed. I mean, the thing here, you can't call this function without this parameter, since it requires a parameter, right? So when you have parameters, we can divide the functions into 4 main types, right? We can divide the function, we can divide functions into 4 main types when you have parameters, when you have arguments in your function, right? In your function definition, if your function takes some arguments, right? If your function takes some arguments, what that means simply, you have to at the function call, you have to provide some values, right? For example, the first type is the required argument type, right? So I will explain required argument type. So we have 4 main types of functions. If you like consider a function with arguments, we can divide it into 4 main types. So first I will discuss the required argument type functions, right? So let us define a function like this. Okay, this function takes 3 parameters a, b, and c, right? This function takes 3 parameters a, b, and c. So let me print those values. Right? Let me print those values. And what I'm going to do, right? I'm going to pass some values like this. Okay. No issue. It runs as usual, right? 10 is passed here. Hello is passed here. This value is passed to C, right? So it works perfectly. But this is where you are going to get an error, right? So it says, okay, what I tried here, that I tried with like, okay, this function takes 3 arguments, right? This function takes 3 arguments, but here I have provided only 2. I haven't provided anything to C, right? I haven't provided anything to C, but you can't call the function like this. What happens? You are going to get an error. It simply says, okay, my function missing positional requirement argument C. These 2 values like will be provided to A and B respectively, and no value to be passed to C, right? No value is there to be passed to C. That's the issue, right? Therefore, you are going to end up with an error. So this is called the required argument type. No matter how many arguments are there, you have to provide them. Right? You have to provide them. How many arguments are there? No matter how many arguments are there, you have to provide each and every one. Right? So obviously this won't work, right? Here, like it says like 2 required positional arguments are missing, B and C. We have provided a value for only A, right? Yes, exactly, right? But this is not practical, right? This is not practical, right? If you have done like Java, or like if you have built some PC application, let's say, right? A PC application, a GUI, let's say a graphical user interface, right? In a graphical user interface, I mean, any other programming language would be fine. When you are going to create a button, right? When you are going to create a button, let's say, for example, we have like more than 20 parameters to be passed, right? Isn't it? Like we have to provide, okay, the button color, the button background color, the foreground color, the text size, the height, width of the button, the hover color of the button, right? So we have to provide lots of parameters, right? But usually when we create a button, we don't provide them all, right? What we do, just we provide the button text, and that's all, right? Button text and the button font, sometimes the color, but we won't provide all the parameters all the times, right? Sometimes we may, but most of the times we will provide like less parameters, right? The button color and the button size and everything, like, right? So in that case, what happens? The values that you are not going to pass will be assigned to their default, right? So if you don't pass the font, that will be assigned to Times New Roman. If you won't pass the size of the font, it will be assigned to like 12. If you are not going to pass the background color of the button, it will be assigned to gray. If you don't pass the font color, it will be like black, right? Likewise, always no need to pass all the values, right? Therefore, required argument type functions won't work all the times. Therefore, what we can do, we can like consider this idea, default argument functions, right? So in default argument functions, what we are going to do is we provide some default values to those arguments, right? We have provided some default values to those arguments, right? For example, we have made a equal 0, we have made b equal x, we have made c equal 1000, right? That's what we have done. So then we have printed a, b, and c, right? Then we have printed a, b, and c. Got it? Right? Right? We have printed a, b, and c there, right? Then what happens? Here you can see, when we pass this, what happens, right? The usual thing happens, right? The usual thing happens, okay. No issue, right? This goes to A, this goes to B, and this goes to C, right? Nothing happened, the usual thing happened, right? The usual thing happened, right? But now, can you remember the last code? If you pass 2 parameters, it gave you an error, right? Now, it won't give you an error here, see, right? So what happened here? This will be passed to A, this will be passed to B, there's nothing to be passed to C, right? Therefore, what happens? Can you see what has happened here? Yes? See what has happened? Yes? What has happened to C? Right? So, this won't give you an error. We haven't passed the value to C. What happens then? The default value provided here, right? So, we have provided default value. So, this is called the default value, right? This is what you call, these are the default values. So, we have provided default value to C. So, what happens? It won't give you an error. The default value will be assigned, right? So, the default value is assigned, right? The default value is assigned. Got it? Now, earlier it gave an error, right? Missing one required positional argument. See, we don't have any parameter, but here we are not going to get an error. What happens here? Okay, you don't pass anything to C, but if you don't pass anything, this default value will be assigned. When you are going to pass, then those values will be assigned, right? But if you are not going to pass anything to that value, the default value will be assigned, right? So now what happens here? So we pass only one value here, right? We only pass one value, right? So we won't pass, we haven't passed like values to B and C. Therefore, what happens? They are assigned to their default, right? B and C are X and 1000, right? So that means they are assigned to their default. Right? Got it? So what do you think? Will this work? My function, we are going to call like without any parameter. Will this work? Yes? What do you think? Huh? Yes. Will this work? Huh? Yes, what do you think? Yes or no? Yes or no? Yes, this will work, right? You don't pass any value, but what happens? A, B, C, and will be assigned to their default, right? So A is 0, B will B becomes X, C becomes 1000. Right? Okay, now I want to do something like this. Let's say I want to pass this 10 to A and hello to C, right? I don't want to pass anything to B. So will this work? Huh? What do you think? What do you think? Huh? Will this work? So what I'm trying to do is, okay, I'm trying to pass this 10 to A and this to C, right? So my question, will this work? Yes? What do you think? Quickly? Yes?
Will null get printed?
Uh,
Null.
yes, actually this won't work, right? So what I wanted to do, okay, I wanted to pass this to A and this to C, right? But it won't work here, right? It won't work here. So you are not going to see anything right here, right? You are not going to see anything. You can't do it like this, right? You have to always follow the order, like, okay, this can be done. Then the C won't get any value here, only A and B, right? Got it? Only A and B, right? So this is the solution, right? Keyword arguments, right? So what do you mean by a keyword argument is that, right? Here also you have to like always keep the order in mind, right? Okay, so first one goes to A, second one goes to B, third one goes to C. So if you take a practical example, when you are creating a button, you have to always remember, okay, the first parameter is the button text, the second parameter is the background color, the third parameter is the foreground color. Likewise, you have to always keep the order in your mind, right? So what happens here, in keyword argument functions, no need to keep the order in your mind, right? So here now we know that the first value will be passed to A, the second value is passed to C, and the third value is passed to, the first value is passed to A, right? The second value is passed to B, and the third value is passed to C, right? So you know that, right? But here we can do it like this as well, right? So we can no need to keep the order in your mind, right? No need to keep the order in your mind. What you can do, you can call the keyword like this. Okay, I'm asking to pass this value to C and this value to A and this value to B, right? So no need to keep the order in mind. This is the practical thing. Otherwise, like let's say you have a function which takes 20 parameters, right? You have a function which takes 20 parameters. So you have to keep the order in your mind, right? But if this is the case, no need to create the, no need to keep the order, the argument order in your mind. You can call the keyword and pass the value, right? You can call the keyword and just pass the value. Got it? Right? Okay, so my question, what happened if you run this one? Can you like predict me the output quickly? So these functions are called keyword argument type functions. Yes. What will be the output of this one? Quickly.
Will it throw an error? Like it would require all the three arguments?
Yes, exactly. This would give an error since we use the keyword and we pass C and A, but we haven't passed anything to B, right? Therefore, still it gives you an error, right? But what we can do, we can combine both default argument. What do you mean by default arguments? In default argument functions, you have provided some default values to the function arguments, right? And keyword arguments, what you can do? You can pass the value by calling the keyword. So that's what you call the keyword argument. So we can combine both of them, right? So here we have both we have the default arguments are also given here. The default arguments are also given here. At the same time, we can call it by the keyword as well, right? So now what happens? You see, the order is not going to be a matter. B will be passed to this one, and the value A is passed to this one. So we are not going to pass anything to C, right? So C will remain at its default, right? C remains at its default, right? Got it? So we can combine both the default arguments and the keyword arguments and get this kind of output. Understood? Right? So this is called the keyword arguments and default argument and required argument. Right? I hope you got it. Right? Any questions you can ask, right? If you have any doubt, you can always ask. So we had four main types, right? So we have discussed about the required argument, the keyword arguments, and also the default arguments. We have discussed about them. Then the other thing is the variable length argument, right? Variable length argument. So bit strange idea, but we'll discuss, right? So here you can see that this function is having only one parameter, right? We have only one parameter here. Right? We have only one parameter here. Right? But you can see a difference here, right? You can see a difference here. What's the difference? That okay, let's say now you know that this is a quite simple case, right? It takes one parameter. It takes one parameter. Right? It takes one parameter. But when you put a star here, right? When you put a star here, this becomes a variable length argument. The idea is a bit similar to pointers in other programming languages, right? Pointers in other programming languages, the idea is a bit similar, right? Idea is a bit similar to the, the idea of pointers, right? Got it? But not exactly the same, right? Not exactly the same, right? So here now, what happens when you put a star here? This becomes a variable length argument, right? So what do you mean by variable length argument? This, when you put a star here, it can take, question, let's see. Yes, it can take many values, not a single value, but it can take many values. Any number of values you can pass there. So here now you can't do it with without a star, right? So here one parameter is there, but you are passing like 6 values, right? Right? So it says my function takes one positional argument, but 6 were given. There is only one, but 6 were given. But when you provide a star, this becomes a variable length argument. Variable length argument in the sense, right? Variable length argument in the sense, the idea here is that it can take any number of parameters. Right? It can take any number of parameters. No matter how many parameters you are going to enter, it can take them all. See, got it? And can you see what is this actually? Huh? Have you seen this kind of a thing earlier? Yes. Are you familiar with this kind of object? What is this? Yes. Have you seen this kind of thing earlier? Yes. Getting answer. Not args. I mean, this A is a variable length argument, but when you print it, you see something like this, right? So what is this actually?
Tuple?
Yes, exactly. It's a tuple, right? It's a tuple. See, it's a tuple, exactly. So now what's the advantage of this thing, right? So is that you can like define a parameter which can take any number of values, right? Any number of values. So the variable length argument, right? So you can pass any number of values. Still it take it, right? So we can take a function to find the average like this, right? So we take a variable length argument, and what we do here is that we get the summation and we like get the average, right? See, so no matter what, we can pass any number of parameters here. Now don't get confused here. This and this are two different things. So here what we have done, we don't take a variable length argument, but what we do is we take a array. We take an array, right? We are taking an array here, but here we are not taking an array, right? What we do is we take parameters. Like earlier case takes only one array, but here we can take many parameters, right? No matter how many parameters you are going to enter, the variable length arguments can return, variable length argument can take any number of parameters. So that's why it's called variable length argument, right? The length is varying. You can vary the length according to the parameters, right? Got it? Now we will see the applications of these things, right? Okay. So next thing is the return statement of functions, right? So let me ask a very simple question from you all. So C, C++, Java, other programming language, most of the other programming language, if we consider the function, how many values a single function can return in other programming languages? Yes? Yes, others? Yeah, it's one value, right? A single value can be returned from a function in other programming languages. But in Python, you can return any number of values, right? You can return any number of values. It's not restricted to one, right? Not restricted to one, right? So what do you mean by return of a function, right? So here, this function you can see that it takes two parameters, and what it simply does is take the addition and the total will be returned back, right? So what happens? The function you can take, see that function take 2 parameters, right? The function take 2 parameters, and it get the addition and it return it. So what happens here? If you pass like, okay, 10 and 20, so 10 goes here and 20 goes here, and the return, what happens? It comes here, right? So that's what you call simply a return of a function, right? This is how functions return, right? So what happens here now, if you run this one, you will see the, okay, the value, when you are going to print the value, it's 30. That means this function simply adds it. Now this is simply the function return, right? This is called the function return. But in Python, the most important thing is that it can return what? It can return multiple values. For example, here we have a function. We give 2 parameters, right? We give 2 parameters, and we calculate the addition, subtraction, multiplication, division, everything. And what we'll do, we return all the things. We return everything. We return 4 values here, right? In other programming languages, probably this is not allowed, right? It can return a single value, but in Python, no restriction. You can return any number of value you want from a function, right? Got it? Right? So here, now let me show you. See, I pass 10 and 2, right? 10 and 2. So what happens? 10 and 2 go here, goes here. Right? And addition, subtraction, multiplication, division are calculated. And all of them are returned here, right? So what is this again? Huh? Yes. This is a tuple, right? So that means when you return multiple values from a function, it returns as a what? It returns as a tuple, right? It returns as a tuple. Got it? So can you understand the importance of a tuple now? Something returned from the function cannot be changed, cannot be modified, right? So that means, okay, the return of the function, we are not allowing it to be modified, right? So it's a read-only thing, right? So you can see it's a tuple. Now let's say, okay, if you want to get only the addition from here, so let's say addition, you are going to create a variable, or let's say that you want to get the multiplication, okay, multi equals value. Yes, you can take only the value you want. Let's say 2. From this tuple, you can get a single value, right? It's a tuple, it's a normal tuple, right? So I'm getting the multiplication like this, only the multiplication. So you can see it's printed as 20, right? Got it? Right? And also, if you want to take like, without taking it to a tuple, if you want to get individual values, you can take it like this. See? So now what happens in this case? This goes here. This goes here. Right? And add comes here. And sub comes here to B. And multiplication come here to C. And division comes here to D. Right? So you can do it like this as well without, without taking it to a tuple. What you can do is you can take it to single values. Right? you can take it into individual values as well. Got it? Right. Right. So one last thing about functions. Right? One last thing about functions. The lambda function, so we call it like anonymous functions, right? Anonymous functions. What I mean by anonymous functions, right? The lambda functions, in other words. So this is what you call a lambda function, right? So lambda function, this is how we are going to define a lambda function, right? This is how we are going to define a lambda function. So what I mean by lambda function, these functions are called lambda functions or anonymous functions because they are not declared in the standard manner by using the def keyword, right? You can use the lambda keyword to create small anonymous functions, right? So you can define functions using lambda keyword, right? Without using the def. Without using the def, you can create functions using the lambda keyword, right? So what's the idea of a lambda function is simply that if you have a one line function, a very simple and a very short function, you can, without doing it as a, without defining it as a normal or a general function, you can define it as a lambda function. So that means what? Here, if you simply run it, now let's say here, now this is my function. Let's say I want like, okay, 10 and 2. Right? You can see that it simply returns 12, right? It simply returns 12. So if you have this kind of a very simple function, what you can do is, without doing it like this, using def keyword, and if you have a very simple function like this, no need to use the def keyword and create the function like this, right? No need to do that. What you can do is, if you have a very simple function like this, what you can do, right? You can create a lambda function to that, right? So lambda is a method of creating a function in Python, but this is only for creating like very simple and a very short functions, right? Here. Now, let's say that if you want to create this function without defining it like this, you can define it like this. What it means, okay, lambda, these are the input arguments to the function. Input arguments to the function, and this is the output or the return, right? In the lambda functions, you can have only a single return, right? A single return, and that return, you have to write it as a expression, right? Here it says lambda forms takes any number of arguments. You can take any number of arguments, but return just one value form of an expression, right? So lambda function can take any number of values, right? Any number of parameters, any number of arguments as inputs, right? But it returns only a single value, and that value should be a kind of should be in form of expression, right? It should be in a form of expression, right? Here you can see these are the inputs and this is the output, right? So what happens? This is the function name. This function name takes two parameters and return the argument 1 plus argument 2. So what happens? When you pass this one, it goes here, this goes here, and the addition will be taken and the addition will be returned here, right? But in order to create a lambda function, few requirements should be satisfied. What? Right? Lambda functions can take any number of arguments but return only one value, and that value also should be in a form of an expression, like an equation, right? So for example, now this function makes no sense, right? But yeah, sorry, right? Yeah. So this function makes no sense, right? This function makes no sense, but it takes three parameters. See, it takes three parameters, right? This takes three parameters, and what it returns argument plus argument 2 into argument 3. The important thing, no matter how many values that you are going to get here, right? What you can do is you have to like simply write the return in a form of an expression. You have write it and in a form of expression, right? Got it, right? So that's what you call lambda function. So when you are going to use a lambda function is when you have a function like you can write in one line like this. If you have a function, very simple function, which you can write in one line, you can use the lambda function, right? So lambda functions can take any number of parameters, but can return only a one value, and it should be in a form of an expression. That's all. If you have such a function, you can create a lambda function without creating it in the standard form. Understood? Right? Got it? Right. Good. So any questions from the things that we have covered so far? Right. So please ask if you have any questions, right? So you can you give me a like 1 minute. I will be back in 1 minute. Meanwhile, if you have any questions, you can ask them. Yes, so we have a question here. Right. Let me yeah. So the question was expression separated by yes. Now these are the inputs and this is the return. So the inputs and the return, input and the output is just separated by a colon. So the input and output is just separated by a colon, right? Understood? Right. Okay. Right. Okay. So I think any other questions from your side? Right. So I'm going to now thereafter move to the next topic, the Python modules, right? Python modules and a very another important topic. So all the topics are important, right? So I'm going to move on to the Python modules code, right? The file Python modules. So we will simply discuss about what it means by a module, and we will do some examples as well, right? So I'm in the first code 1.0 Python modules, right? So a module is simply a library, right? So in other programming languages, if you are familiar with libraries, so similar idea is there when it comes to Python, and it's called modules, right? A library, a set of codes, right? A set of organized code, uh, well written, structured code is known as a module, right? A library. So in Python, when it comes to Python, we have three main types of modules or libraries. The first one is inbuilt modules. What I mean by inbuilt modules? With the Python installation, right? The libraries that are being provided by Python, right? They are called inbuilt modules. Right? The libraries that you are going to get with the Python installation, the standard libraries or the inbuilt libraries simply. Right? So the libraries that we are going to get with the Python installation are called inbuilt modules or inbuilt libraries. Right? Then the second part or the second types of modules are custom modules. So what I mean by custom module? Custom module is simply a user defined, can be identified as a user defined module or user defined library. What do you mean by a user defined library or a user defined module? Right? That means we can write our own library. So we can write our own modules, right? So libraries that we are going to write in our own, they are called custom modules, simply, right? Then the third one is external modules. So what I mean by external modules? The modules or the libraries that they provided by the third parties, right? What do you mean by that, right? The libraries like TensorFlow, Keras, OpenCV, scikit-learn, Numpy, Matplotlib, and we have sometimes more than 10,000. We have 50,000 libraries written for Python. Right? So we have many libraries written for Python, but we are not going to look. I mean, we are not going to go through each and every one of them, but we will discuss about the libraries that we want, and the required libraries for this workshop in these 5 days, right? So some of them are given here: OpenCV, scikit-learn, NumPy, Matplotlib, Pandas. So those are external modules. So these external modules should be downloaded from the internet and installed in your Python, installed into Python, right? The external modules needed to be downloaded from the internet and needed to be installed to Python. That's something that you have to do. They are not coming with the Python installation, right? The third-party modules or the external modules are not coming with the Python installation. What you have to do is you have to download it from the internet and install it in your Python, right? So that's what you have to do simply. Understood? Okay. Yeah. So now what I'm going to do, I want to show you how we can use modules in Python, right? How we can use modules in Python. Therefore, in order like explain you the basic and the general usage of a module or a library in Python, what I will do is I'll take a inbuilt module, a simple inbuilt module, the math module, right? The math module, and I'm going to discuss some attributes in the maths module, but don't think that we are going to we will use math module in our workshop. No, we won't use math module in our workshop. Not required for us, but to explain you the basic usage and the general usage of a module in Python, I'll take this math module. Other than that, maths won't be used in our implementations. And these are some other inbuilt modules available in like Python, datetime, OS, random, tickinter, CSV, right? So maths is for like basic math operation, and datetime is for taking the real date and time. OS is for the operating system. Functions like shutdown, create new files, right? Copy new files, delete new files. So that kind of operating system functions you can use OS. Tkinter is the standard Python library for graphical user interface creation, right? Email, likewise, we have lots of inbuilt libraries. So these are coming with Python installation. That's why it's called inbuilt. So in order to explain you the basic usage of a library or a module in Python, for that explanation, I'll take the math module and I'll explain the basics of that math module, right? Okay, so in order to use the module in your code, first you have to import it to your code, right? Otherwise, you can't use it in your code. So import is done by this. Import the keyword import and the module name, right? The import keyword and the module name. So here there's example, right? So in a module, you will find lots of things, right? In a module, you will find lots of things. A module can define functions, classes, and variables. So these are the things, these are the three main things that you can see inside the library or a module, right? A module can contain functions, classes, and variables, right? So now don't worry about classes, but let's say, okay, simply a module can have functions and variables, right? So here, now inside the math module, there is a function called POW. How do you know that? Yeah, I will explain. I'll explain how to get the functions and everything available inside this math module. I will explain it, but just assume, okay, there is a function called POW. So this POW simply takes two parameters like 2 and 3 and it provides the power. Power in the sense like 2 to the power 3 like this. Right? It can provide this value. It can return this value, right? I will explain how to get, how to see what are the functions available in libraries. But what I wanted to show here, okay, there's a power function in math module, right? If you want to use it, you have to call it like math dot, right? So what it mean by, like, if you want to call a function, variable, or a class in a module, you have to call it by the module name dot always, right? So here now we pass 2, 3 and it returns us the value, return us the power, and we print it. So here you can see, right? It gives you 8 simply. And the other thing, right? So you can, we have another function called log. You can get the log values like, okay, let's say 100 to the base 10. See? So there are lots of functions available in math. Don't worry about the functions available in math. We are not going to use it. I want to show you the general and the basic usage. But the important point here, if you want to call a function or a variable or a what you say, a class inside the module, you have to call it by the, right, the library or the module name dot, the function name or the variable name or the class name, right? Now you may be wondering, okay, we have functions, we have libraries like matplotlib, TensorFlow. So that means always TensorFlow.matplotlib.matplotlib. Is it? No. What you can do is you can load the library into a custom name like this. Import math as M or import math as MT. Any name you like. You can load the library into any name you like. Import math as M. Likewise, right? So for example here, right, m.log, right? m.log. Now not math.log. Hereafter you are going to use it as m.log. Got it? Right? The other thing is, no need to load the whole library, right? No need to load the whole library. Instead of that, what you can do is you can load only the required functions or required variables or required classes from the module, right? From math, I'm going to import the log and the factorial, right? So what happens then here? Now, no need to call it like math dot or the math dot log or math dot factorial. No, you have loaded the log and the factorial separately into a class. You are not getting the whole math library, right? You are not going to get the whole math library. Instead of that, what you'll do, you'll get the log and the factorial. So if you get them separately from the math module, no need to call them like, okay, math dot log or math dot factorial. No need to do that. Then you can directly call it by the function name here. See, no more math dot. From math, import log or factorial, log and factorial, right? So here also factorial. Now you know what factorial is, right? So 6 factorial. Right? That means 6 into 5 into 4 into 1. Right? Got it? So anyway, now the idea here, if you import only the function, then no need to call it like math dot or the library name dot. No need to do that, right? And also the other thing, you can load it to a customized name as well. From math, import factorial as FC. Right? See? So then like what we are doing here, from math, we import the factorial as FC, right? Got it? Right. Now, don't think that others are going to work here, right? No, others won't work. Like if you want to now, let's say, get the log. No, this won't work, right? This won't work. If you want that, you have log, right? Either you have to do it like import math as m, then you can call it like m dot, right? Or else you can do it like this, from math import log. Then no need of m dot, right? Got it, right? The other thing is, this is one import thing, from math import star, right? So what this does, if you do it like this simply loads all the functions and the variables and everything available in the math to your code, right? Now everything works here, everything in the sense, now the power, the log, and whatever the things or the functions and the things available in the math module works here, right? Everything works here. See, everything works here now. Got it? So this is simply what? From math import star, that means you are going to load each and every function and each and everything available in the module, right? So it's like from math import factorial. Now here we are only loading the factorial function, but import star loads each and every function and all the attributes available inside the function. I mean the module.
Dakshil, I have a question.
Yes.
Yeah, with that kind of a thing, does it import? Is it valid on all the other library?
Yes.
Or is it only valid for math function?
No.
Math library.
Yeah, no. This is valid for every library, but not recommended.
Every library.
Not recommended.
It's not recommended to do?
Yeah.
Okay.
The reason is, now this is quite okay for math, but if you take a library like TensorFlow, right?
Mm-hmm.
So TensorFlow library, it's like itself, like I think 500 megabytes, right? The library itself.
Okay.
Right? So if you load it to your code, it will be like issue with your RAM, not exactly, but not, I mean, it will like reduce the speed of your code. That kind of things can be happen.
Okay.
Therefore, it's
Mhm.
not recommended to do it for each and every library. For math kind of
Okay.
simple library, it's possible, but very large
Mhm.
libraries, not recommended to do that. So for
For
large,
matplotlib,
yes,
libraries like the plotting libraries like matplotlib.
yeah, yeah. I mean, for like external libraries, this is not recommended since external libraries are like
Okay, this is not recommended.
few
Okay.
megabytes, right?
Okay. Mhm.
That's the case.
Yeah. Thank you.
So in those
Yeah.
kind of libraries, what the most important, I mean, what's most the convenient thing to do is this. You can load whatever the functions you need, whatever the functions you required in this code.
Okay.
You
Mhm.
can load whatever the things required to your code. You can import, or you can import those functions only, right?
Okay. Mhm.
And if you need to have an idea what are the functions and what are the things available in a specific function, I mean, a specific library or a module, you can import that module and you can call the help function, help, and you can pass the module, I mean, the module name. Then this gives you a very comprehensive uh, uh, comprehensive details about the function, right? I mean, the functions available in this module, right? So it says, okay, math, name is math, description. This module is always available. That means it's a standard module, inbuilt module. It provides access to the mathematical functions defined by the C standard, right? So cosine, tan, right? Cos, exponential, fabs, factorial, gamma, like we have lots of functions, right? A lot of mathematical functions are there. Log, log 10, log 2, power, radian, sine, right? And also these are the variables available. What do I mean by the variables? Now the pi, infinity, exponential. So these are like, okay. So you can import math as m, let's say, and m dot pi. So this is a pi value, right? Likewise, got it? So these are variables available, right? So it can contain variables as well as the functions. Right? Okay, now what I want to do here, I'm not going to go through each and every library like inbuilt libraries, OS, and everything. Not necessary for our implementations. I will walk through only. I mean, I will walk through the libraries. I wanted to explain math since I wanted to explain the general usage of a library, right? But now what I'm going to do, I will show you what's actually inside the uh, module, right? So let me do something like this. So I'm in this location, whatever where your code located, right? Yeah. So I will do something like this. Now I'll yeah, I do something like this. I'm going to get a not Jupyter notebook, but I will get my text editor, a normal text editor. It can be a Notepad++, Sublime Text, anything, any text editor, right? So what I'm going to do is I'm going to take a new file, right? And I'm going to save this where my current codes are. So my current codes are here. This is where my current codes are, right? So I'm going to now, what I'm going to show you here, how to create your own library, own module. Then you will understand what actually happens inside the module, right? So let me define a file, a Python file, .py file, right? Call my math, right? So this is a raw Python file, not a IPython notebook, right? AIPYNB, no. not IPYNB. So what we mean by IPYNB? IPYNB is a notebook file. That's the file extension going to provided by the Jupyter Notebook files, right? But what I'm creating is a raw Python file. So when you are creating your own module, you need to have a raw Python file, right? So I'm going to create a raw Python file .py, and I will do something like this: def add. So I'm going to create a function which takes 2 parameters, right? And I return the addition of these two. And then I'm going to get my average function, let's say, which can take a variable length argument, and this return the sum of a divided by the length of a, the average, right? And I have a variable one, var 1000, right? So these are the only files available in my right? And this is located here. See, now this is my code actually. No, I'll create a new code, right? So this is my code, and this is in my working location, current working location, right? So what I'm going to do now, I'll take a new file, right? I'll take a new file called, okay, Python 3 testing my module, right? And if you go here, see, this is here as well as this is also here. This is my code that I just created, this one, right? And this is the Jupyter Notebook file that I just created, right? Okay, so then let me take it to this side. Okay, so now let me show you how to use this module. Now this is actually a module written by me, my math, right? See, import my math. My math is this file name, right? My math. Then print, okay, value equal my math dot add 10 to print. See, now this is what you call the module simply, right? Then I can like from math import average. See, and my math dot var. See, so you can understand what's a module now. A module is simply a Python code, right? See, a module is simply a Python code, right? So the implementation is hidden. The implementation is hidden, but you can use it like this. Now you will understand, okay, import my math. So my math is simply this file name, right? File name, and we import it, right? And we import the functions, and like we can get something done here. So this is simply what a module is, right? So understood, right? So let me show you something, right? Let me go to my Anaconda installation. So I think my Anaconda is installed, yeah, here, Anaconda, right? And in this folder, you will find a folder called lib, right? We'll find a folder called lib, and this lib contains all the inbuilt modules in your computer, right? All the inbuilt Python modules are included here, right? All the inbuilt modules are here, right? So if you like, this is tickinter, can you see tickinter? And if you search for OS, probably OS is available, right? See, OS is available, right? And date time is also available. Can you see? Right. All the standard modules are here: math module, OS, email, right? CSV, like all the inbuilt modules I just showed you. These are available here, right? And in this one, so this contains all the libraries in your computer, right? So this contains all the libraries in your computer. And also, there is another folder called site packages. Can you see? Another folder called site packages. So these site packages contains all the third-party modules that you are going to install to your computer. Right? All the third-party modules that you are going to install to your computer. Right? So now in my computer, I have installed like Numpy. So Numpy probably available, right? And TensorFlow would be available. See, and OpenCV probably available. Here, OpenCV, right? And all the Flask, right? Here. So all the third-party modules are installed to the site packages, right? So they are installed to the site packages folder. Got it? Right? Right? Okay. So now, so when you import, right? When you import a module, first it looks whether this module is available in your working location, right? So it's check whether this module, now when you are going to provide, when you are trying to import a module, it will check whether that module, that kind of a Python file is available in your working location, right? Or else if it is not available, then it goes here and looks here where, I mean, it checks whether that library is available here, right? So first it looks in your current working location. If it is not available there, then it looks here, the, what you call, the lib folder, right? Got it? Understood? Right? So this is where your libraries are installed in your computer, and site packages contains all the third-party modules, right? So how to install these modules? Like, okay, these TensorFlow, scikit-learn kind of libraries, how to install them, right? So it's a very simple procedure. Yeah, we have a question. Let's see. Can we create all our own modules in one folder and give the path in the file while import? Yes, exactly. You can do that. Yes, you can do that simply, but yes, yeah, you can do that. What I was looking for, like, Yeah. So if you like, if you want to now you can like if you want to create your own library, you can do that, and also you can include it in the lib folder as well, right? So you have to do some simple steps rather than this. You have to follow some simple steps, and you can convert it to your own module as well, and you can include it in the lib folder, right? So I will explain about those things later, but you can create your own modules and load it anywhere you want, right? You can load it from any path you want as well, right? But one thing I want to explain, right? So the third-party modules, how you are going to install them, right? You can open the Anaconda prompt, right? You can open the Anaconda prompt, and what you can do is in the Anaconda prompt, there's a command that you can run, pip install, right? Pip simply stands for Python package installer, right? Pip install for Python package installer, Python install package, Python package installer. So pip install, then you can give the module that you want to install, right? That's the one important thing, right? So these are, I mean, the scikit-learn, Numpy, all of these are third-party modules, right? These are third-party modules. All of them are third-party modules. But I told you in the first video that I provided to you regarding the Jupyter Notebook configuration. In that module and in that video, I told you that Jupyter Notebook is specially designed development environment, and this Anaconda navigator is a specially designed development environment for machine learning, data science related fields, right? Machine learning and data science related fields. So this Anaconda navigator is a specially designed uh, set of development environments. Therefore, these like scikit-learn, right? Numpy, matplotlib, panda. So these libraries are coming as inbuilt for Anaconda navigator. That means Jupyter Notebook, right? So when you install Jupyter Notebook, these will be installed. But if we are using any other environment like Python idle, PyCharm, or any other development environment, these won't be available, right? Therefore, what you have to do is you have to install them separately. But if you are using Anaconda, right, you can install the library. I mean, if you are using Anaconda, these libraries are available as inbuilt, right? But anyway, let me show you how to. So that means scikit-learn, NumPy, Matplotlib, pandas, no need to install them. But other libraries like, okay, if you want to install Flask, this is how we are going to do it. Pip install Flask and enter. So this will download it from the internet for you, and it will install it in the site packages. No need to do anything manually, right? Everything will be done by the Python package installer. You have to just run the command. Everything is done by the Python package installer. So if you want to install OpenCV, this is needed for our implementations in tomorrow, right? We need the OpenCV library. So this is how we are going to install the OpenCV. Pip install OpenCV. Now it's not installed in my one since I have already installed them, right? I have already installed them. There's a question how to do this in PyCharm, right? So if you are using PyCharm, you can open the PyCharm and open a terminal and run this command. Open a terminal and run this command, right? Open your terminal and run this command. That's all, right? And right, if you we are not going to talk about TensorFlow in our workshop, but don't install this. If you are like, if you want, if you can install, but this is how we are going to install the TensorFlow. Pip install TensorFlow. So what I wanted to show you here, that you can load those. I mean, you can simply install them using this keyword, pip install whatever the library name. whatever the library name you can provide, and it will install it for you. Got it? Any library, pip install library name, so it will download it for you and it will install it to the site packages. Right? It will install to the site packages. Right? Right? Got it? So you can open the Anaconda prompt and use the pip install command. Pip install whatever the library name. So the Python package installer will install it for you. Right? Got it? Right. Right. So any questions from the sections that we have covered? I mean, from the module section. Okay. Right. So then we will move on to our first third-party module that we are going to discuss in this course, right? So that's Numpy, right? Numpy. So we will be like discussing about several Numpy, Matplotlib, OpenCV, then scikit-learn, Flask. So we will be discussing about these things. The first thing that we are going to discuss about Numpy, and Numpy and Matplotlib, if you take Numpy and Matplotlib, if you take, so this is this provides us lots of functions, right? So Numpy provides us, so if you have used Matplotlib, sorry, MATLAB, if you have used MATLAB earlier, MATLAB, if you are familiar with something called MATLAB, a software called MATLAB, whatever the things that you can do in MATLAB can be done in Numpy and Matplotlib together. If you take Numpy and Matplotlib together, you can do anything that you can do in MATLAB. You can do them in Python if you use Numpy and Matplotlib, right? So very powerful library. Numpy and Mat libraries are like MATLAB and Numpy are very powerful libraries. So Numpy is there for performing multi-dimension array operations, right? Multi-dimension array operations or matrix operations, right? So if you are going to deal with arrays or multi-dimension arrays or matrices, the Numpy is Numpy provides you very useful libraries and some it provides you very useful functions you can use in matrix operations. Now actually we are going to discuss about image processing and machine learning in coming days. So we are going to deal with data, we are going to deal with images, right? So when it comes to images, when it comes to data sets, right, we have to always deal with arrays, right? So data sets are arrays, images are arrays. So therefore it's quite important to learn Numpy before moving on to image processing or machine learning, since we are going to find arrays and we have to perform multi-dimension array operations in coming weeks, coming days under image processing and machine learning. Therefore that's why we are going to cover Numpy first, since Numpy has lots of functions we can use for array operations, right? Got it? And matplotlib is the next library that we are going to discuss. Matplotlib provides you lots of functions and lots of facilities where you can draw, where you can use it for graphical representations like visualize, dataset visualize, data trace, to check the distributions of data sets, to check the characteristics, and to check the you can plot 2D arrays, you can do 3D arrays, you can draw line arrays, you can draw scatter diagrams, you can draw pie charts, you can draw bar graphs, you can draw histograms, anything using matplotlib, right? So we are going to discuss about Numpy and matplotlib, and you are going to get like the basic idea about matrix operations and data visualization. This is a very good and very important topic before going on to machine learning and image processing. So that's why we are going to cover it now, right? Okay, so we will discuss about the basic functions and the most useful functions available in Numpy. Don't think that we are going to cover each and every function in Numpy. No, right? So if you go to this tutorial, so this is this tutorial is provided by the tutorials point, and you can see there are lots of topics available in Numpy, right? So Numpy is if you like discuss about Numpy, if you completely discuss about Numpy, it would take like 5 days workshop, right? It will take like all the 5 days, and we can discuss only about Numpy. No, we are not going to do that. We are going to like cover the most important and the most important and most useful sections to our coming sessions like image processing and machine learning. So those are the like what we are going to discuss is only the required, right? The most important and the useful functions, not all, right? But you have lots of resources provided, and you can go and you can learn more if you want. So what we discuss is simply what we need in this workshop and what we need to complete the remaining sections like machine learning and image processing. The sections that we are going to, the sections that we need from multi-dimensional arrays will be only covered in this Numpy tutorial, right? Not all. Okay. So you know what array simply, right? So if you take a 2D array, so this 2D array, you can see rows, right? Rows and columns, right? And like the 0, 0 start from here. Now this is not like the Cartesian plane, like no, not 0, 0 start from here. No, 0, 0 like start from here, right? So this is where 0, 0 located, right? And we say like, okay, rows and columns, and in computer, you know, numbers start from 0, not from 1, right? So we say, okay, this is row 0, row 1, row 2, and this is column 0, column 1, column 2, and column 3, right? So if you take a single element, right? If you take a single element like this, right? Array 1, 2, array 1, 2, array 1, 2, right? Array 1, 2. So that's what you call 24, right? So that's what something about indexing in 2D arrays, right? So this is something that you already know, right? So if you have a 2-dimensional array, this is how we are going to represent it, right? If you can represent a single value like this from the row number and the column number. The most important thing is that the indexing starts from 0. No matter it's a row, no matter it's a column, start from 0, right? So if you take that 24, that can be represented like array 1, 2, right? Okay, so this is simply what you call a multi-dimensional array or a matrix, right? So here this is a 2D matrix, right? So, right, so in order to use Numpy of functions, right? In order to like use the matrix operations, so Numpy simply provides you lots of functions to perform matrix operations, right? Numpy provides lots of function to provide, implement matrix operations, right? Therefore, if you want to get some matrix operations done from NumPy library, right? If you want to get matrix operations done using NumPy library, you have to first convert your already available arrays or your already available lists into NumPy arrays, right? NumPy functions works only with NumPy arrays, right? Got it. So if you want to use the functionalities of NumPy library, you have to first convert the already existing array. If you have already existing array, it can be a list, it can be a tuple, anything. You have to first convert it to a NumPy array, right? So this is how we are going to import the NumPy library, import NumPy and as NP. So most of the times we use NumPy as NP. You will see this in codes. Everyone imports NumPy as NP, so it's kind of a standard. Not necessary, but kind of a standard now. Everyone does it like that, right? Anyway, so here now, this, what is this? Have you seen this earlier, right? So this is a, yes, a 2D array, right? But this is a list, right? You know this is a list. Why? Why I refer this as a list?
Separated by commas.
Yes, actually, you have here square brackets, right? Square brackets. That's why I refer it as a list. And this is a 2D list. Why I say like 2D? Now, if this is like this, you can't probably understand, right? What is this? Right? Got it? You can't understand what is this actually, right? But actually,
List
this
of
is,
list.
yeah, exactly. So this has 3 rows, right? And each row you can have like 4 columns, right? So if I like change the structure to this, now you will understand. The same thing, I just enter it to a new line, right? That's all what I did, right? So this is a 2D array, right? 2D list to be exact. So this is a 2D list. Now, you can't do array operations using NumPy library if you are having a Python list. No, right? You can't do any array operations with Python lists, right? So if you want to get this function, I mean, NumPy has very important and very powerful and very useful functions where we can use it for array operations, right? Multi-dimension array operations, right? In the definition, it so says, right? See, NumPy is a library consisting of multi-dimension array objects and a collection of routines for processing those arrays, right? Got it? So in order to get the benefit of them, those routings and those functions, we have to convert it to NumPy array, and this is how we are going to do this. np.array. NumPy, there's a function called array, np.array, and what we have to do is we have to provide a normal Python list or whatever the list or array, and this will convert it to a NumPy array, right? So I have printed the array here, so you can see the array 1. So this is the original array, right? So this is the original array, and what we have done here, I have taken something called array new, right? I have taken something called array new, and I pass this array here, and I have taken something called array new, and when you print array new, you are going to see something like this, right? You are going to see something like this, and see, so this is a NumPy array now, and no difference, right? Not that much of a difference, but converting it to a NumPy array, converting an already existing list into a NumPy array is quite useful, since like Python, other contributed libraries use NumPy arrays everywhere. For example, images that we are going to discuss tomorrow under OpenCV, images in OpenCV are NumPy arrays, right? data sets in scikit-learn are NumPy arrays, right? Neural networks in TensorFlow, most of their weights and biases are NumPy arrays, right? Most of the data sets are NumPy arrays, and other libraries also use NumPy arrays for their implementations, right? Other modules are using NumPy arrays, right? So NumPy array is a very powerful object, right? So that's why always we are trying to convert something into a NumPy array. Then we can perform lots of functions using NumPy to these arrays, right? And we can get lots of things done, right? And here a one-dimensional array, a single 1D array is available here called X. So you can convert 1D arrays as well. So simply what you have to do is, no matter what's the dimension, you can np.array and it gives you the array. And this can be also used. This is an alternative. np.asArray does the same thing, right? np.array or np.asArray does the same thing, right? So once you have a NumPy array, so here this is the array one, and we have converted to a NumPy array, right? So how to convert it to a NumPy array? np.array. So this simply convert it to a NumPy array. So in a NumPy array, you can take these attributes. This is an NumPy array, you know, right? So we have, now we had the Python list and we convert it to a NumPy array, and this contains a NumPy array. So from a NumPy array, simply we can get the dimensions, the number of dimensions, right? So this won't work for, I mean, Python lists, right? So, okay, so this is a Python list. So if you like take the ending of a Python list, no, it won't give you anything, right? List object, no attribute ending, right? Or it gives you an error. But NumPy array, after converting it to a NumPy array, it gives you the ending. So it gives the number of dimensions of this array, right? It says 2. What does it mean by 2? So it says in this array there are 2 dimensions. Yes, what it means by 2D? 2 dimension. I mean 2. Yes. It simply says this array 1 has 2 dimensions. What it means by that? Yes. Any idea? It has number of dimensions. So ndim gives you the number of dimensions. What it mean by ndim? Number of dimensions. So it says a 2D array, right? It's obvious, right? See, this is 1D, this is another D, another dimension, right? So rows and columns, it says simply. So 2 dimensions are there, right? So for example, if you like create this kind of array, what would be the number of dimensions of this one? Right? Yes? How many dimensions are there for this array? Yes? How many? This is a 1D array, right? See? So it says 1, right? So there's another attribute we can use that's called the shape. So array under ending, array ending, so ending gives the number of dimensions of this array, and the shape gives you full details. What do you mean by full details? 3, 4, right? So it says, okay, array 2, ending says that it has 2 dimensions, and shape gives you like 3, 4. What it means by 3, 4? So if you want like see the array new, I can print it. So what is mean by 3, 4? Any idea? The shape is 3, 4, it says. What it mean by 3, 4? Yes? Yes, 3 rows and 4 columns, right? So it gives you the exact number of rows and columns, right? Exact number of rows and columns. Right? Got it? Um, right. I think you can understand what happens in the shape, right? So these are very useful, right? So I will show you the functionality of these things, right? Okay, right. So the other thing is that, yeah. So let me quickly show you the remaining, right? Yeah. So we have discussed about shape and endim. So you know, when it's a numpy array, we can get the number of rows and columns or the any shape using the shape array name dot shape array name dot shape. So it gives how many rows and columns, right? And endim gives how many dimensions are there. It's a 1D array, or it's a 2D array, or it's a 3D array, or 5D array, anything, right? So then I'm going to talk about two important functions available in NumPy library, right? A NumPy library. So here, let me take the same array as the earlier case. Let me take the same array as the earlier case. So this is the array that we were considering about, right? So you know its shape is like 3, 4, and we can use this reshape command, right? Reshape command. See, array1 dot reshape 4, 3, and I'm going to take it to array 2, right? Array1 dot new reshape 4, 3, and I'm going to take it to array 2, right? So if you run this one, what has happened? So the array is now reshaped into 4, 3. It was 3, 4, now 4, 3. Now, can you see? Very powerful functions are available in NumPy, right? So we can reshape a already existing array, right? So here again, I have the array 1, I have reshaped it to 6, 2. See? 6 rows and 2 columns, right? And I have converted it to 12, 1. What do you mean by 12, 1? 12 rows and 1 column. See? And 112, what it means, right? But don't think that you can do like this, right? So you can't do it like this. Okay, what happens here? Can I do it like this? What happens? Any idea? Yes, what do you think? Can I do it like this or not? Yes, quickly.
No.
You can't, right? Why? Any idea?
There should be 30 elements, but we have only 12
Yes,
elements.
exactly, right? So that's the reason here, right? There should be like, there are only 12 elements here, right? There are only 12 elements here. So how we can get 30 elements from that? It cannot be done, right? It cannot be done. So that's the reason. That's the I mean, right? That's the only reason. Exactly, that's the reason. Right? So you had like consider about this. So it gives you an error simply. So if you run this one, it gives you an error. Right? Let me show you. Okay. See? So it says it has only 12 elements. You can reshape it to like this shape. Right? Okay. So the other function, now you know what reshaping, right? So reshaping, what the reshaping simply does, right? But let me show you the np.arrange, what we can do using the np.arrange function in Numpy, right? So np.arrange is similar to like the syntax of the for loop, right? -10 plus 10, 2, right? And we are going to create an array, np.arrange, and you are going to provide 3 values here. So this will be the starting value, and this is the ending value, and this is the what? The step size, right? So if you create an array, you can see an array like this, right? So array values are starting from 10 and ending from +10, and the step size is 2. Similar to a for loop, right? But it creates an array here, right? So if you print, can you like, okay, if I print the array.endim here and array.shape here, can someone tell me what you are going to get quickly? Any idea? Yes, quickly. Any idea?
The array first, then 1,
Okay.
then 10 comma 1.
10 comma 1.
1 comma 10.
1 comma 10. Almost correct, but it only gives you 10, right? That means it's a 1D array. If it is, yeah, you can say endim is 1. That means it's a 1D array. So you don't have rows and columns there, right? So if it is a 1D array, no rows and columns. There is nothing called rows and columns in the 1D array. They are just like 10 values. Just 10 values. No rows and columns in 1D. 1D simply says, okay, just 10 values, right? Got it? But here I will show you the difference, right? So you can reshape it like this is a 1D array, 1D array, that means 8 values, but you can reshape that array. If you use like -1 plus 1, if you use -1 plus 1, this makes no sense, right? What do you mean by -1 plus 1? If it is like 10, 1 or 5, 2, right? If it is 5, 2 or something, it's quite like it makes sense, right? Let's say, okay, 5, 10, right? 5, 10. So what it does simply, okay, then it's fine. Like we have 10 values and we provide it like, okay, 5, 2, then 5 rows and 2 columns. It's okay. It makes sense. This makes sense. But what do you mean by -1 plus 1? Shall we run this and see what happens? Right? So it creates you a column vector. What do you mean by a column vector? If you have one column and many rows, it's called a column vector. Now this is 2D. Now this is 10-1. Now this is 2D now. Earlier it wasn't 2D. It's like 1D. 1D means only one dimension. That means 10 values just. But here now you have a column, a single column and 10 rows, right? So -1 plus 1, reshape -1 plus 1 simply converts a single dimension array or 1D array into a column vector. Column vector, that means it makes it 2D, but 2D in the sense one column and many rows. So it's called a column vector. So then you will understand what happens here. 1 minus 1. Yes, 1 minus 1. The other way around. What? Huh? So it creates you a row vector. So if you have one row and many columns, one row and many columns, so it's called a row vector. 1, 10. One row, 10 columns. Understood? So now you may be wondering, okay, why you are specifically covering these things now? Reshaping, converting 1D into a 2D. What do you mean by row column? This 1D, 2D meaning, yes. This is important in our implementations in coming days, right? So that's why I am covering these things. The difference between 1D arrays, 2D arrays, and how to reshape it, right? Got it?
Sir,
Yes.
excuse me. So, in 21st code part, so 10 also can also be given, right? So specifically minus 1, 1 we are doing.
Sorry, I couldn't get you. I couldn't
I
hear you
mean,
clearly.
array dot shape of minus 1.
This one.
So a reshape of minus 1, specifically, no, 21.
Okay.
21
Yeah.
code script. Yes. Why specifically minus 1, 1, we can go it like 1. Okay, if sure how many are there for that purpose? Am I clear?
No, it's not.
Am I clear?
No. I think, yeah.
Hello?
Hello. Yeah, your internet connection, something issue with the internet connection. Yes. Can you please repeat it once? Let's see.
No. So we can then 1, 10. But if we are not sure of the number of files there,
Yeah. Exactly.
primary
Now,
my 1 and
yeah, I think what you are asking is, right, okay, we can do it like this as well, no? Right? 10, 1, right? You mean, yeah, the same thing, right? So if we compare the two, the same thing. So why you are using, like, without doing it 10, 1, why you are using minus 1 plus 1? Yes, exactly. Like if you use minus 1 plus 1, no need to count the number of rows available there. Or no need to count the number of values. It, like, without having an idea about number of values available, if you do like minus 1 and plus 1, it makes a column vector. But this also makes a column vector, but here you have to manually like provide what's the value. I mean, how many values are there, right? Yes, exactly. So without knowing the size, you can use minus 1 and plus 1. Yes, exactly. So when you go to data sets, so some data sets contain thousands, some data sets contains like millions of values, right? So you can't always have an idea about how many values are there. So this simply you can use it. No need to take no need to have an idea about like how many values are available. You can just provide minus 1 and plus 1, and so it reshape it, right? It reshape it. No need to have an idea about how many values are there, right? Very good question, right? Okay. Then the next one is array creation routing. So how to create arrays in Numpy, right? How to create arrays in Numpy. So we have several methods. So we will discuss about a few, right? So if you want to create an empty array, this is how we are going to do it. X is the array name. The function that you are going to call in Numpy is empty. And here you are going to provide the size 3, 2. So what do you mean by 3, 2? 3 rows and 2 columns. And the next parameter is the data type, right? So it's create you this kind of array, right? Now you may be wondering, okay, this is not an empty array. There are some values. No, actually the case is now it creates an uninitialized array of specific shape and D type. We have provide the shape like, okay, 3, 2, 3 rows and 2 columns. And the data type is integer, so it creates us an integer array. Fine. The elements in the array show a random value as they are not initialized. So we haven't assigned any values yet. Therefore, it shows us some garbage values, some random values. So don't worry about them. So this is simply creates an empty array. The values, so if you have some values, they are just garbage values, right? Got it? So this is how we are going to create like an array with zeros. array with zeros. Similar to empty, you can create an array with zeros, all zeros, right? See, now this is creating a 5 rows and 3 columns, but the data type here is float. Now there is a one small issue in Numpy arrays. That issue is actually you can't simply create arrays which can save anything, right? Which can save anything, right? Which can save anything in the sense like NumPy arrays can either hold integers or they can hold in floats. Okay, they can hold strings, right? One single array can't hold everything, right? There's a issue like that, but Python list can, right? But NumPy arrays are not capable of holding anything, right? So we have to provide the data type. So if it is float, it can hold floats, but a float can hold integers as well, right? It's fine, but strings cannot be assigned, right? So here we create the data type float. So this means like it can hold 5 rows and 3 columns of zeros. Later you can assign values there, right? Later you can assign values, like if you want to assign a value, okay, the first row, right? First row and the second column, I'm going to assign 1000, right? So thereafter, let us print x. Later you can assign values, but initialization, right? So you can see first row, second column, 100, right? You can assign values later, but this is how we are going to create them, right? And this is the same shape array, but with the integer data type, right? Got it? And similarly, zeros you can create ones as well, okay? Ones as well. So what I mean by ones? Zeros, ones, you know, right? But don't think that we can create twos, threes, fours, five, six. No, you can do it like that. Only ones and zeros or empty. Okay. And the other thing is that now why zeros and ones, right? There are a few reasons, right? There are a few reasons. Now, I will show you one example later in the coming day, right? So when you are going to create a black image, pure black image, that will be like zeros. All the pixel values are zeros. If it is a like white image, you can create it with ones. That means all the pixels become white. So likewise, if you want to create a full black image, you can make zeros. If you want to create a full white image, you can create it like this. Shall I show you? Right. Okay. Like let's say we create right 500 image, and we need matplotlib, so don't worry about. Now don't worry about matplotlib. We will discuss about matplotlib. See, black image, 500 by 500 black image, right? So once I think it should provide. No, it's yeah. CEOs. Let me create like 50-50 image. Not 50-50, like okay, 10-10 image. Okay, right? So what I'm doing here? Right. See, I create an image of like 10 and 10, right? Size 10 and 10, and it's like zeros. And I create like 5, 5, I make it 1, right? 5, 5, I make it 1. So see, can you see? 1 pixel becomes, right? 1 pixel becomes white. You got it? Now don't worry about this. I just wanted to show you like why always ones and zeros. You can create even images, right? So this is the 5, I mean, you can see, right? 5 column, 5, right? 5 row and 5 column. It becomes, right? So don't worry about matplotlib and everything. I will discuss about them in detail, right? Okay, so we know the range and we have done that. And indexing and slicing. Right. So this is a very important thing to be discussed. So we will yeah, we will discuss like we have 3 more minutes. So we 2 more minutes. We'll discuss about few here, right? So anything we will do tomorrow, right? Anyway, now if you want to create an array with random values, right? This is how we are going to do that. np.numpy.random.random integer. Now, okay, the functions that we have covered up to now, they are okay, right? Why they are okay? Okay, np.arrange, np.zeros, np.1. So what it means? Okay, numpy library function arrange, right? So numpy library function ones, numpy library function zeros. But what it means by numpy.random.random integer, right? So it simply means something like this. Let me show you. Right? So if you go to the libraries, let me go to the site packages and let me go to the numpy. Here numpy. So can you see that numpy, inside numpy there is a folder called random, right? So what this means, in the big numpy library, there is a sub-library called random, right? There is a sub-library called random. In numpy, we have a sub-library called random. So that's what it means, right? There's a sub-library called random, right? So that's what we are doing here, right? If you see numpy sublibrary random integer, right? So it's calling the random integer function available in sublibrary of numpy, the sublibrary random, right? So this simply creates some values, random values, right? So this is like, okay, we'll start from here. So within brackets, the third parameter. So you can see that we have to provide 3 parameters. First parameter, second parameter, and the third parameter. Third parameter is a tuple, right? Third parameter is a tuple, you can see. So what it means, the tuple, simply you have to provide the shape 10, 5, right? And this is the value range 0 to 100. So what it means, this one creates an array in size of 10, 5, right? With values between 0 to 99, right? Got it? So it creates an array with random values, and the range of the values, random values are 0 to 100. The low and the high values you have to provide, right? So this is a shape. This is a shape, right? Got it? So array equal np.random random integer 10, 5, and values in between 0 and 100, 0 and 99 simply, right? Now if you run this again, the values get changed, right? Why? It's a random function, right? It's a random function. Okay, so then one last thing, yeah. Probably I will discuss about these things tomorrow, right? Since already time is up, right? So we'll discuss about the remaining part, the indexing and slicing. So that's what we have to cover under this topic, the indexing and slicing. So we'll discuss about this topic and the Numpy, and we will start then the image processing with OpenCV part tomorrow, right? Okay. So any questions from the session today? If you have any questions that we need to be discussed, any errors you are getting in your codes, anything to be clarified, any issue in your creating your environments or codes in the Jupyter notebook, you can share your screen so I can fix those issues if you want, right? That can be done, right? So if you have any issue or if you have any errors in your codes, I will help you to fix those things, right? Or any doubt, anything to be explained again, I can help you, right? Yes. np.random was np.random random integer, right? So np.random simply says like, it says, uh, yeah, yeah. So then it says like, okay, np.random says, okay, np.random, that means from NumPy takes the sublibrary random, right? But here says np.random, that means np's NumPy sublibrary random, from that take the random integer function, right? np.random simply says, okay, the sublibrary random, right? And random.integer simply like provides you the a function available in the sublibrary random. Got it?
Hello.
Yes. Yes, Sai.
Hello.
Yes. Yes, I can hear you.
Sir, the doubt which I had is while coming to np.random.
Yes.
Hello. While coming to np.random and at np.random.randin, what
Yeah.
is the difference between those if we don't like what are the values that lies between by default without giving initializing them like 0 to 100?
Yeah. Um,
See, you wrote, like np.random.randid 0 to 100 4 comma 3. Will there be any default values without writing 0 comma 100 without mentioning 0 comma 100? Will we get any output?
you mean like this? Is it?
Yes, removing them. Yes, yes, yes.
Yeah. Um, so it gives you like 0, 3. Um, um,
So we should mention the range itself.
yeah, I think,
Is that it?
yeah, 0 and 3, what this means. I'm not sure, but anyway, uh, yeah, you have to provide the two values, otherwise it won't work.
Range.
So
Yes,
this is like the minimum, and yeah, you can, it creates integers, so you can provide like any range here.
yes. Okay. Can you try with random too, sir? Same. No.
Yeah, this one, right? Okay. Um, np.random, right?
Just remove randint and try.
Yeah.
Yes, yes,
So this can use the same thing, is it?
yes.
Yeah, that's what I said, right? So np.random, it's a module. right? It's a module in the sense like it's a submodule, but it's also considered as the module, right?
Okay.
Got it? So we like numpy
Yes.
submodule random, from that submodule call the random integer function, right?
Yes. We shouldn't call. We should not call random. Is it?
Yeah, you can't. But there's another function like a Python function called random, right? Like this.
Acha, okay.
There's a separate function called
Ah,
random. It's a Python function, right? So you
okay.
can, I'm not sure about the parameters, but random dot random integer, is it? I'm not sure whether it's available. Let's see. Yeah,
It's okay.
right. So this
Yes.
is separating. This is a standard Python library, right? So it
Yes.
provides
Yes.
you a value between 10 and 20, right? I'm not sure about you. No. Yeah, it's only take 3. Yeah. Right. So this gives you a value between 10 and 20 simply, right? So this is I think if you can remember, this is the inbuilt Python function,
Yes.
right?
Thank you.
Okay. So any other questions from your side? Okay then, since we don't have any questions, so therefore let me conclude the session from here, and I will provide you the link today itself to the recorded video. And the other thing is that tomorrow we will complete the remaining part of NumPy, and we will go to the matplotlib as well, and also we will start the image processing with OpenCV tomorrow, right? So very interesting, don't miss it. We will be implementing lots of like image processing based applications tomorrow, right? So see you tomorrow. Thank you very much and have a good night.